Okay, lesson 12. It's going to be factoring special quadratic functions. And we've this shouldn't be too much more difficult, I wouldn't think. We've kind of been doing stuff a little bit similar to this earlier, but we'll just jump right into it. This is what I mean by special quadratic functions. So you can see that it looks like a big mess until you kind of simplify this a little bit. I can see that this 3m plus 5 is in both of these, right? So what we're going to do is we're going to say x is equal to 3m plus 5. And that way we can rewrite this thing with just x instead of this whole mess here. Then when we're done factoring, we'll put this back in and then we'll simplify. And here's what I mean. So let's rewrite this, but instead of 3m plus 5, everywhere there's a 3m plus 5, I'm going to write an x. So I'm going to say x squared plus x minus 12. Now I can factor that, right? So we can factor this by writing our brackets. We've got an x and an x. And we need to multiply to negative 12 and add to 1. So what about 3 and 4? And then the 4 would be positive and the 3 would be negative. Okay, so all we had to do was factor and that would be it. But now we need to put these back in place here. So what we're going to do now is everywhere there's an x, we're going to throw 3m plus 5 back in. So we're going to have, and I'll make that a different color maybe. Let's make it blue. So 3m plus 5 is going to go in there, plus 4. And then instead of x, I'm going to write 3m plus 5. And then bracket, and then minus 3. So now we just need to be able to simplify this, right? And since there's nothing being multiplied by x in either of these cases, this one's pretty straightforward. We can actually just kind of lift the brackets. The brackets don't even really need to be there anymore, right? On either of them. So we can really just rewrite this as 3m plus 5 plus 4 times 3m plus 5 minus 3. And collect our like terms. This just becomes 3m plus 9 times 3m plus 2. So there, those are our factors there. All right, next one. Okay, you can kind of see the same type of process happening again. We're going to say, okay, maybe let's use a different letter though, because x is the one that's in there. Let's say y is equal to x minus 1. So this is going to be y and that's going to be y. So let's rewrite this as 3y squared plus 10y minus 8. Okay, now I can factor this, right? But we got to do this isn't 1 out front, so we need to do the whole multiply add thing. So the numbers that I'm interested in here, they need to multiply to, well, 3 times negative 8, negative 24. They need to add to positive 10. What about 6 and 4? Would that work? So 6 and 4 would not work. So what about 12 and 2? Yeah, that'll work. So that would be positive and that would be negative. Okay, so I'm going to rewrite this now as 3y squared plus 12y minus 2y minus 8. I'm going to factor this part first on its own and then this part. So the first one is I'm going to factor a 3 out of that and a y. So I'm going to factor out 3y. And then I'm left with 1y plus 4. And then on this side, I'm going to factor out a negative 2. So negative 2. And I'm left with y plus 4. So my factors here are 3y minus 2 and y plus 4. Okay, now don't forget we need to put this back in place for y. So if we do that, we've got 3 and then x minus 1 minus 2, and then y here is x minus 1 plus 4. Okay, now though, we need to make sure that we do this right. We have to go 3 times both of those first before we simplify. So now we're going to have 3x minus 3, and then that minus 2 is just kind of hanging out there, so minus 2. And we've got, now these brackets can just lift. I don't need to do anything else to that. So we've got x minus 1 plus 4. Let's just collect our like terms. We've got 3x minus 5, and then x plus 3. Okay, so I'd like you guys to pause this now and give it a try, and then I'll continue on and do it afterwards. So go ahead and pause it now. Okay, let's do number 3. All right, so first off here, let's call this x. So we're going to say x is equal to 3a minus 1. All right, so let's rewrite this. It's going to be 6 times x squared minus 21x plus 15. Now we just need to factor that. So all of these things, 6, 21, and 15, you can divide all of those by 3. So let's take a 3 out of this. Let's factor a 3 out. So we've got 3, and then I'd be left with 2x squared minus 7x plus 5. Okay, now let's factor this part now. So the numbers that we're interested in here are going to multiply to positive 10. They're going to add to negative 7. So what about 5 and 2? And negative 5 and negative 2. All right, so we're going to have 3, and I'm going to rewrite all this stuff as 2x squared minus 5x minus 2x plus 5. We're going to factor just these, or this part on its own, and then just this part on its own. So we've got 3, and then I'm going to factor out just an x is all I can do. So just x, and then on the left-hand side, we're going to have 2x minus 5. Over here, we're going to have minus 1 is all we can factor out. So we're going to factor out the negative sign there. So I'll just factor out negative 1. And then I'll be left with 2x minus 5. Close the bracket. We've got 3 times x minus 1 times 2x minus 5. Now, we just need to put 3a minus 1 back in place there. So let's keep going here. This is going to be 3, and then times, and instead of an x, I'm going to write 3a minus 1. And then there's another minus 1 there. And then over here, we're going to write 2, and then instead of an x, we're going to go 3a minus 1. Don't forget to put the brackets there so you know that you have to distribute the 2 into it. And then minus 5. Okay, let's simplify this a bit. We've got 3 times, this is just, the brackets can kind of just lift on this one because there's nothing that needs to be distributed through. So we've got 3a minus 2, and then times, I need to multiply this 2 into both of those things. So this is going to be 6a minus 2 minus 5. Let's write it all again. We got 3 times 3a minus 2 times 6a minus 7. Okay. Moving on. So factoring difference of squares now, though. This is something else to kind of look at, that now this part in the brackets doesn't look like this part in the brackets. But that's okay. Let's just call this part A, and let's call this part B. So I'm going to say, well, let's maybe do different colors too to kind of keep that separate. So call that A. So A, we're going to say, is equal to 2x minus 1. B, we're going to say is equal to y plus 3. Okay, now let's just rewrite this with A and B instead. So we've got A squared minus B squared. And I know how to write that out as difference of squares. That's just going to be, let's do it all one color here now. That's just going to be A minus B and then A plus B. Now that I know that, we just need to plug these things back into it. So instead of A there, I'm going to write 2x minus 1 and then minus. Make sure that these are all in brackets because this is going to become important here. So minus, and then B was y plus 3, and then close that bracket, and then start again. So, and then A was 2x minus 1, and then plus, and then B was y plus 3, and close that bracket. Okay, so now this is going to become just 2x minus 1. That bracket can just kind of like go away. There's nothing that needs to be distributed in. But on this part, don't make a mistake here. This is like negative 1 out front, right? We need to distribute that negative sign through that. So it needs to be negative 1 times y, negative 1 times negative 3. So this would become negative y, or negative 1y. And then this part would become negative 3. And then close that bracket. And then open it up. And then this part is still just 2x minus 1. And then there's nothing to distribute through this one, right? It's all just positive signs, so it all stay the same. So this is just going to be plus y plus 3. Let's collect our like terms. This will become 2x, negative 1, and negative 3. That's negative 4. I'll maybe put the y here first, though. So it'll be negative y and then minus 4. We just kind of like to put the numbers on that are on their own, put them on the end is the only reason. Now we're going to have 2x plus y, and then negative 1 and positive 3, so plus 2. Okay, let's keep going. Now we got the same kind of situation, right? Let's call this A, and let's call this B. So A is going to be 3x plus 2. B is going to be y plus 1. Okay, so now we've got 27a squared minus 75b squared. So it looks like a difference of squares. It's close. What I'm going to have to do first is I'm going to divide both of these by 3. Or factor out a 3, you could think of. So 27 divided by 3 was 9. So if I factor out a 3, I'm going to have 3 and then 9a squared minus 75 divided by 3 is 25b squared. And hey, both of those are perfect squares. So now we can treat this like a perfect square question. So now we've got 3, and then this is going to be 3a minus 5b, and then 3a plus 5b. Now we just got to put our numbers back in there, what a and b equaled. So we've got 3. Maybe make it a square bracket just to kind of show it's different, and I don't need to. Yeah. Okay, so now we're going to have 3, and then a was 3x plus 2, and then minus 5, and then b was y plus 1. Okay, and then close the square bracket. You can see the square brackets are just a little bit easier to kind of keep straight now, because a square is straighter than a curve. Okay, so now we've got 3, and then a was 3x plus 2. Okay, plus 5y plus 1. Close the bracket. Okay, now we're going to have 3. We have to distribute in the 3, right? 3 times 3x, 3 times 2, and all the way like that. So this is going to be 9x plus 6 minus 5y minus 5. This is going to be 9x plus 6, and then plus 5y plus 5. Okay, we're almost there. We've got 9x. I'm going to make 5y the next one, and then we're going to have plus 1 when you collect our like terms there. And left over here, we've got 9x plus 5y, and then plus 11. Okay, last one. And again, I'm going to let you guys pause it now. Give this one a try on your own, because there will be one like this on the test that I think it'd be worth you guys giving a good try. Yeah, so go ahead and pause it now. Okay. And what we're going to do, we're going to call this, let's call that A, and we'll call this B. Okay, so let's rewrite this. Here, I'll say what those are. A is going to be equal to x plus 2. B is going to be x minus 3. So let's rewrite this as 32a squared minus 18b squared. So looking like a difference of squares type of question. Looks like we can factor something out though. We can factor a 2 out of this. So it's going to be a 2. And we're going to have 16a squared minus 9b squared. Which is perfect because 16 and 9 are both perfect squares. So now we can do this. It's going to be 2. This is going to be 4a minus 3b, then bracket 4a plus 3b. All right, now we just gotta plug in these values for a and b. So this is gonna be 4, and in place of a, we're gonna have x plus 2, 3, and then in place of b, we're gonna have x minus 3. Now 4, x plus 2, and then plus 3, x minus 3. All right. 4x plus 8 minus 3x plus 9, negative 3, negative 3. And then 4x plus 8, and then 3x minus 9. Okay, now we got a few like terms to collect here. We're going to have 4x minus 3x, that's just going to be x. And then 8 plus 9, that's going to be 17. On this side, we've got 4x plus 3x, so that's going to be 7x. And then positive 8 minus 9, that's going to be minus 1. Okay, that's going to be it for our special cases of factoring. We'll give you guys a few examples when we're reviewing for our test, but that's pretty much it. The next thing we're going to be doing is our final for this unit. So good luck, guys.